Okay, so in this video we're going to look at a proof by induction exam question involving inequalities, and it's worth 15 marks. So this is a carry on from question 2, where up in parts A and B they had given you the function f of x and g of x, and then they follow on and say, prove using induction that f of n is greater than or equal to g of n, where n is greater than or equal to 2 and n is an element of the set of natural numbers. So just for us here, if f of x is 3 to the power of x, then f of n will be 3 to the power of n. And similarly, g of n will be 4n plus 1. We just swap x out for n. So we'll set it up here. So they're telling us 3 to the power of n is going to be greater than or equal to 4 to the power of n plus 1. So proof by induction, as always, step 1. We're going to prove true for n equals 1. Get 3 to the power 1 is greater than or equal to 4 times 1 plus 1. They told us n was greater than or equal to 2. So I would have seen there pretty quick, 3 to the power 1 is 3, 4 ones are 4 and 1 is 5, and that statement is wrong. So usually if you've made that error that I just did there, you won't get past the first step. So that's kind of maybe a fail-safe in that sense. So 3 squared will give you 9, will be greater than or equal to 4 twos are 6 plus 1. So we get 9 is greater than or equal to 7. So it's true for n equals 2. Then our second step, we're going to assume true for n equals k. So that gives me 3 to the power of k be greater than or equal to 4 times k plus 1 plus 1. So 3 to the power of k greater than or equal to 4k plus 4. Sorry, that's 4k there. I'm a step ahead of myself. 4k plus 1, and we multiply out 3 to the power of k is greater than or equal to 4k plus 1. Our third step, we're going to prove true for n equals k plus 1. So we have 3 to the power of k plus 1 will be greater than or equal to 4 times k plus 1 plus 1. So that's 3 to the power of k by 3 to the power of 1 greater than or equal to 4k plus 4 plus 1. Again, I'm kind of keeping step 2 in mind, so that was 3 to the power of k greater than or equal to 4k plus 1. So I'll just swap this order around. And again, same time here, so 3 to the power 1, we can just leave as 3 now. And then if we have a look here, we have 3 to the power of k, and there we know from step 2 that that's true, and then it's 3 times that, so it's going to be greater than 4. So just then at the end, you can maybe make a note here. So 3 times 3 to the power of k is going to be greater than or equal to 3 times 4k plus 1. So that gives you 12k plus 3 will be greater than or equal to, so you can swap that out for your left hand side, and you'll get 12k plus 3 greater than or equal to 4k plus 1 and 4. You can tidy up to 5. Essentially I'm kind of doubling up on my proof here, but no harm. And then we have 12k is greater than, we have it done there, so we know there that that's going to be greater than that because it's 12 times. We'll be subbing the same number in here, and then we just, because it was n greater than or equal to 2. Again, we put the same scenario in there. So if you double check, 2 12s are 24, and 3 will give you 27, and then 4 2s are 8, and 5 is 13. 27 is greater than 13. You can even test it for 1, but it's not necessary. So 12 by 1 will give you 12, and 3 is 15, greater than or equal to 4 1s are 4, plus 1, or plus 5 is 9. So 15 is greater than 5. So just here we have 12 times 2. So that's 27. Just our statement at the end, we feed it back to them. We have 3 to the power of n is greater than or equal to 4n plus 1 for all n greater than or equal to 2. N is an element of the set of natural numbers, as we have proved true for n equals 1 and n equals k plus 1, assuming true for n equals k plus 1. Okay, and that's us done there for 15 marks.